Have you ever pondered the question, what if our current digital computing methods are not the best we can do? Indeed, digital computing has taken us to the moon and back, revolutionized communication, and transformed our everyday lives. But as we delve deeper into the 21st century, the limitations of binary computing are becoming increasingly evident. We're hitting a wall with Moore's law, which predicted the doubling of computing power every 2 years. The miniaturization of silicon chips is reaching its physical limits, and the power consumption is skyrocketing. The world of technology is crying out for a revolution, a new paradigm of computing. Enter Spintronics, a fresh approach that exploits the intrinsic spin of electrons and the magnetic moment associated with it, rather than relying solely on their charge. This could be the game changer, offering a new horizon beyond binary. So, can Spintronics be the revolution we need? Let's delve deeper. Spintronics, or spin transport electronics, may sound complex, but its principles are based on the fundamental properties of electrons. Let's start with the basics. Everything in our universe, including electrons, spins. This isn't spinning in the way a top or a planet does, but rather a quantum mechanical property related to angular momentum. Electrons can spin in one of two ways, often referred to as up and down or spin up and spin down. This is where Spintronics comes into play. Now imagine being able to use that spin, not just the charge of the electron, to store and process information. That's the heart of Spintronics. Unlike traditional electronics, which use the charge of electrons, Spintronics exploits both the charge and the spin of electrons to carry information. This allows for a much denser storage of data and potentially faster and more efficient processing. But how does this differ from our current binary computing system? Well, binary computing, the backbone of our digital world, relies on bits. These bits, which stand for binary digits, are the smallest unit of data in a computer, and they're represented as zeros and ones. The state of a bit, whether it's a 0 or a 1, is determined by the presence or absence of an electrical charge. Spintronics, on the other hand, uses something called spin states to represent data. In this system, the up and down spins of an electron can represent the binary states, 0 and 1, but it doesn't stop there. Because of the quantum nature of electron spin, these particles can exist in multiple states at once, leading to the potential for quantum computing, where information can be processed in parallel, dramatically speeding up computation. It's like comparing a two-lane road with a multi-level, multi-lane superhighway. The possibilities for data transport and processing become exponentially greater. Understanding these principles illuminates why Spintronics holds such potential for transforming digital computing. And as we delve further into the world of Spintronics, we'll explore how this technology could revolutionize everything from data storage to artificial intelligence. The implications of harnessing electron spin for digital computing are far-reaching and revolutionary. Let's dive into the potential capabilities and performance improvements of Spintronics compared to current digital computers. The whole world of digital computing has been built on the binary system, zeros and ones, on and off switches. But what if we could add another dimension to it? That's where Spintronics comes in. By utilizing the spin of electrons, Spintronics introduces a whole new level of data representation, effectively adding a third state to the binary system. This means that the data processing capabilities of digital computers could be exponentially increased, opening up a universe of new applications and advancements. Now, let's talk about Spintronics logic gates. Much like their counterparts in conventional digital computing, these gates form the building blocks of all computational tasks. However, instead of using the presence or absence of an electric charge, Spintronic gates use the up and down spin states of an electron. This not only results in more complex and efficient computations, but also significantly reduces energy consumption. You may be wondering, are there any devices that already utilize Spintronics? The answer is yes. The most common example is the hard drive read head in your computer. These devices use the giant magnetoresistance (GMR) effect, a fundamental principle of Spintronics, to read data from your hard drive. But this is just the beginning. Researchers are working tirelessly to unlock the full potential of this revolutionary technology. Picture this: quantum computers that can solve complex problems in seconds, energy-efficient devices that can run for days without recharging, and ultra-fast networks that can handle the data demands of billions of devices simultaneously. The potential of Spintronics is immense, but it's the performance gains that truly set it apart. The future of digital computing is not just about processing more data, but doing it faster, more efficiently, and in ways we've never imagined. And that future is being shaped by the revolutionary potential of Spintronics. Imagine a world where computers are exponentially faster, more efficient, and more reliable. This is the world that Spintronics is working to create. The potential performance gains of Spintronics are truly staggering. To start with, let's look at processing speeds. Traditional binary computing is limited by the speed at which electrons can move through a material. But with Spintronics, we're dealing with quantum properties. Information is processed through the spin of electrons, which is almost instantaneous. This could lead to processing speeds that are orders of magnitude faster than anything we've seen before. Next, consider power consumption. The binary system uses a lot of energy to move electrons around. But with Spintronics, the electron stays put and only its spin state changes. This could lead to a drastic reduction in power consumption, making our devices not only faster but also much more energy efficient. Finally, let's talk about data storage. The unique properties of Spintronics could allow for much higher data density than traditional storage methods. In essence, we could store more information in less space, which could revolutionize everything from our smartphones to data centers. In all these areas, the potential gains of Spintronics are not just incremental improvements. They represent a quantum leap forward, a fundamental shift in how we process and store information. Spintronics doesn't just promise a revolution, it's poised to deliver one. As we've seen, Spintronics has the potential to redefine the future of digital computing. This game changer works on principles that differ vastly from conventional binary computing. Its potential lies in its new capabilities and performance improvements, which outshine today's electronic digital computers. From Spintronics logic gates to already existing devices utilizing Spintronics, the performance gains are truly promising. The revolution in digital computing is not a question of if, but when. And Spintronics might just be the catalyst we've been waiting for.